Welcome. For those of you that need to learn or just need a refresher on long division, you've come to the right place. Let's talk division. Now, if I asked you to take a dozen eggs and divide them among 4 people, how many eggs does each person get? I hope you were immediately able to tell me it's 3. Now, one of the cool things about division is that if I then asked you to take that dozen eggs and divide it among 3 people, how many eggs does each person get then? What you get in that case is the other divisor, 4. Now, doing division by being solid with our times tables is good, but that doesn't really work when the problems get a lot larger or when the chunks don't divide out evenly. For those times, there's long division. I'll show you one and explain every step along the way. Then I'll show you another one that's a little bit bigger, and it doesn't work out cleanly. It leaves a remainder. Before we jump into showing the examples, though, I'd like to talk for a second about how numbers are built. See, when a number gets big and it has multiple digits, it's important, especially for the purpose of long division, to understand that each digit has a value. Not just the value you see in its number, but also the value that it earns as a result of its place in the number. 6284 is made up of the 4 digits 6, 2, 8, and 4, but the 6, by nature of being over there in that 4th position, is actually worth 6,000. The 2, because it's in the 3rd position, is worth 200. The 8 here in the 2nd position is worth 80, and the 4 here in its last position is simply worth 4. This number is 6,280 and 4. Long division calls on us to respect those values as we go about doing the division.
So let's try a long division problem. A relatively simple one, and I'm going to give you a promise you won't ordinarily get from long division. This one's going to work out nicely. We're going to start with the number 192. And we're going to divide 192 by 8, divided by 8. Now, I'm not going to write divided by 8 off to the right, because we're doing this as a long division problem, which means we write it to the left and create a long division bar. Now, the question we're asking is, 192 divided by 8 results in what? 8 times what makes 192? Or how many times does 8 go into 192? Now, the answer is 20-some, but that's too big for us to think about at one shot. So we're not going to try to take the 8 into 192. Instead, we're going to try to take the 8 into just as much as we need. How many times does 8 go into 1? Well, that unfortunately doesn't make any sense. It's not a full answer. 8 doesn't go into 1. So we won't be able to do it with just the first digit. We'll go ahead and move into the second digit. How many times does 8 go into 19? Remember, it's not really 8 going into 19, it's 8 going into 190. But we're dealing with this chunk by chunk. So how many times does 8 go into 19? The answer to that is 2. Again, and I know I'm hitting on this a lot, that means that 8 goes into 192 20-some times, but we're only dealing with the first couple of digits of the dividend first. So 8 goes into 19 2 times, but it actually has some left over if we take 8 into 19. So our next step is to say if 8 goes into 19 2 times, let's take that much out and see how much remains. So to take some out, we're going to have to take our new chunk of our quotient and multiply it times our divisor and see how much of the dividend we can remove as a result. 2 is part of our quotient. We're going to multiply that times the divisor, 8, and wind up with 16. That's the amount we're going to be able to remove from the dividend. Our next step, and this is where all the sign errors wind up happening, is that we have to take that 16 out of the dividend and see how much remains. I'm going to take that 16 and subtract it. So 19 minus 16, or rather 190 minus 160, leaves me with 3, or 30. Now 30 isn't all that remains from the dividend. There's also the 2 that remains up here. That's part of the remaining dividend and should be brought down now because we're ready to use the ones digit. When we found that 2 was the first digit of our quotient and multiplied it against our divisor to remove some from our original dividend, That removal left us with a remainder of 32. Now that remainder can still be divided by 8. So we're back to the beginning and asking ourselves a new question. 8 goes into 32 how many times? The answer, of course, is 4. Now we're not sure if that's everything, so we're going to take this 4 that we've created in the quotient and multiply it by our divisor to see if we've taken away everything we need to. 4 times 8 makes 32. And remember, to be mathematically rigorous, we are taking away that 32 from what remained from the dividend. 32 minus 32 leaves us with nothing. We have removed the entire dividend, and that means there is no remainder. The quotient, and therefore the solution to our problem, is 24. And because of the way division works, 192 divided by 8 is 24. 192 divided by 24 is 8. And 8 times 24 is 192. Let's try it again, only this time it's not going to work out quite so nicely. We're going to take 192 and this time divide it by 5. Now, if you remember any of your division rules or even your times tables, you know that 5 is not going to go into something that ends in 2 evenly. We will have a remainder. I'll explain what that means. The long division process is the same. We're asking how many 5s are there in 192? 192 divided by 5 leaves us with what? 5 goes into 192 how many times? That's too big to work out in one shot. So instead, we're going to say how many times does 5 go into just the first digit? 5 goes into 1. Well, that doesn't make any sense because it's not a full 5. So we'll go ahead and use the second digit as well. 5 goes into 19 how many times? That's a total of 3. Once more, for clarity and the reason why this works, we're not asking how many times 5 goes into 19. That's just for convenience. We're asking how many times 5 goes into 190. The answer is 30. But our ultimate answer is going to be 30 something. We'll get the rest of it here in a minute. So 5 goes into 19 3 times, but it has a little bit extra. So we're going to take the 3 times the 5 and find out how much we should take away. 3 times 5 is 15. That's what we're going to take away from the dividend. And because we are taking away, it is a minus problem. If this had worked out to be negative, by the way, we would have changed it to positive because it's a minus problem. The 19 in the dividend with 15 being removed from it, really 190 in the dividend with 150 removed from it, leaves us with 4 in the tens column. So there is 40 some remaining in the dividend to be divided out. We have a 2 that's up here in the original dividend. We're going to go ahead and bring it down now because we're ready for it. Everything has now been brought down, by the way. Everything from the dividend exists on this line. And we're going to ask our final question. 5 goes into 42 how many times? Well, it's 8, but it's 8 and some left over. So let's find out how much left over. The 8 times the 5 leaves us with 40. And that's what we're removing from the dividend, leaving us with 2. 2 is all that remains from the original dividend that wants to be divided by the 5. And our next step would be to say 5 goes into 2 how many times? The answer to that question is less than 1. So we wind up with a decimal result or a remainder. Either is correct, so you have a choice. You can either turn this into a decimal value, which doesn't change the original value. It just looks at it in smaller and smaller and smaller chunks. And you can bring down those decimal values and continue finding out what the decimal result in the quotient is. But what I'm going to do instead is I'm going to choose to respect the fact that there is 2 from the original dividend that wants to be divided by 5, but can't be because it won't work out evenly. That is what wanted to be divided, so let's divide it. In a very real sense, we're leaving this instruction for the next guy. Whatever 2/5 is, it's part of the quotient as well. So we have an answer. 38 and 2/5 is the quotient of the division problem 192 divided by 5. It would also work out to say 192 divided by 38 2/5 would leave us with 5. And of course, there's the final truth that 5 times 38 2/5 would give you 192. And it's just as accurate to say that the quotient is 38 with a remainder of 2. And it's also just as accurate if you were to continue dividing out into the tenths and hundredths digits that 38.4 is the quotient for this particular problem. But I think for the purpose of making this make the most sense, saying that the answer is 38 with 2 remaining that wanted to be divided by 5 is the quotient of 192 divided by 5. Let's do one more a little bit faster and with a little bit less explanation. Let's take 6284 and divide it by 3. I don't know what the answer is. Let's find out. Now, 6,284 being divided by 3 is going to leave us with an answer of 2,000 something, but that's way too much for me to figure out in one swoop. So we're going to figure it out part by part. We're going to take the 3 not into 6,284, but instead just into 6,000. 3 goes into 6 2 times. Now we're going to remove that 2,000 times 3 from the dividend. 2 times 3 leaves us with 6,000. And we'll subtract now to see what's left. 6 minus 6 leaves me with nothing. So what's going to come down will be the next digit, 200. 3 goes into 2 how many times? Not enough. So we're going to need to leave a 0 up here to say that we weren't able to take anything out at this point. And instead, we're going to get some more of the dividend and see how much we can take out now. 28. 3 goes into 28 how many times? I believe that answer is 9. Really, 90. And 9, or 90, times 3 leaves me with 27, or 270. How much of the divisor did that take away? All but 1, which is in the tens column, so really 10. Finally, bring down all that remains from the dividend that wants to be divided, that single digit 4. 3 goes into 14 how many times? That's a total of 4. Because 4 times 3 gives me 12, that's the most I can get. We'll subtract that 12 off of the 14 and be left with 2. 2 remains from the original dividend and wants to be divided by the 3. 3 goes into 2 how many times? Not enough. And so we have a remainder. How much remainder? A remainder of 2. I think, however, it makes more sense for us to say that it is 2 which wanted to be divided by 3. There we go. 6,284 divided by 3 is 2,094 2/3. 6,284 divided by 2,094 2/3 would be 3. And perhaps most importantly, 3 times 2,094 2/3 would get us back to 6,284. That's long division. It's a repeated process of taking your divisor and dividing it into chunks of the dividend and finding out what that leaves in the quotient until you've taken everything out of the dividend, at least as much as you can. And if there's anything left, that's your remainder. Long division is not incredibly hard. It's just that there's a lot of pieces moving all together. And the best advice I can give you is try to remember at each step, what is it you're trying to accomplish? Not what's the step you're trying to do. What is it you're trying to make happen? I hope that helps. Good luck.